Hey guys, we're looking at numbers 55 through 57, and we're looking at static friction. Okay, let's look at the first situation. We've got a stationary object. It's the mass of 15 kilograms, stationary. That means the velocity is 0. This is on a table located near the surface of the Earth. Coefficient of static friction, so mu sub s, is 0.4, and the coefficient of kinetic friction is 0.25. Okay. In number 55, it asks, it says that there's a horizontal force, we'll call that force applied, of 20 newtons, 20 apples, is applied to the object. Okay, part A says draw a free body diagram with the forces to scale. All right, so let's do that. Free body diagram shows that the force applied, 20 newtons. There is a weight. There is a normal force, which is equivalent to the weight in the opposite direction. And there's also going to be a force of friction here. Okay, we don't know what that is yet. Okay. First thing is we want to determine the force of friction. Okay, now we got 20 newtons for a stationary object. So let's see what happens here. Because it's stationary, we're looking at static friction. Stationary, static. So let's find that. Okay, first of all, we're going to figure out the weight of this object. So it would be 15 kg times negative 9.8. Okay, the weight of it's 147, so the normal force is equivalent to that, but in the opposite direction. That is 147 newtons. So let's go and figure out what the frictional force is on this stationary object. Let's see if that gets it to accelerate. Force of friction, mu sub s, 0.4, times the normal force, 147. 0.4 times 147. So the force of friction on this object would be 58.8 newtons in this direction. Now take a peek at it. Friction will never cause an object to move. So when I pull on it to the right, the frictional force will break at 58.8 newtons. So if I were to increase this force to 58.9 newtons, that would break the friction and cause it to start to accelerate. So we'll call this the potential friction. But in reality, the friction of this object, if pulled with 20 newtons, is up to 58.8 newtons. So the force of friction on this object is 20 newtons if I'm pulling on it with 20 newtons. Okay, hopefully that's understandable. Force of friction can never cause the object to move. It can only go against the applied force. So if we're pulling on it with 20, we know it's going to pull at least with 58. So we got to crank that up to at least 59 or 58.9 to get it to start to accelerate. So the force of friction in this case will be negative 20. That was part B. Part C was very simple. What is the acceleration of the object? Well, if I can't get it to move, it's not going to accelerate. So the acceleration is 0 meters per second squared. Okay.